Mrs. Flock's science. Da, 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 da. So today's task is to draw the dot and cross diagrams for a covalent bondedly molecule of water. So the formula of water is H2O, and this is a student's work that we're looking at to see how they've attempted this question. So they've correctly drawn the outside shell or energy level of oxygen showing 6 electrons, and they've drawn hydrogen because water contains hydrogen and oxygen. And they've missed the fact that there are 2 hydrogens. So they've drawn 1 hydrogen but put 2 electrons in the outside shell or energy level. The 2 atoms are not connected, so they're not bonded, and we haven't got a molecule. This is the next student's work. So we've got some improvement here because we've got 2 hydrogens, each of which has 1 electron in the outer energy level. And we've got an overlapping circle to show that we're bonded in a molecule, but we haven't got the oxygen. So unfortunately, we haven't got H2O, we've just got H2. So we haven't got water. Now this student has correctly identified 2 hydrogens, H2, and each one has got 1 electron in the outer energy level. And they've shown the oxygen with 6 correct electrons in the outer energy level, showing 2 pairs and 2 single electrons. But they haven't connected the atoms, so we've just got 3 separate atoms. We haven't got a molecule of water. Now in this student's work, you can see that they've got 2 hydrogens, they've got an oxygen, so they've got H2O. They've got 1 electron on each energy level of hydrogen, and they've got 6 electrons around the oxygen's energy level, which is correct. And they've got overlapping circles to show they're joined in a molecule. However, in the overlap, they've only got 1 electron on each hydrogen, and they've forgotten that a covalent molecule should have shared pairs of electrons. So this is the perfect answer. This is the bee's knees, and it shows 2 hydrogens, it shows 1 oxygen, so H2O, and it shows overlapping circles, so we've got a molecule, and it shows the correct electrons in oxygen of 2 pairs and 1 in each overlap, and for hydrogen 1 electron in each overlap. And now we have overlaps with pairs of shared electrons, which is what makes a covalent bond. And when we describe this, we've got to say there's electrostatic attraction between the atoms and the nuclei of the atoms and the shared pair of electrons. As I said, this is the perfect answer for water's covalent bonding. So, having learnt about covalent bonding, now we need to think about the skill of application. Because in the exam, they will ask you to apply the knowledge you have to a new situation. So here we have an example of an exam style question. So at the top, they give you a piece of information which is designed to link to the previous part of the question. And that simply gives you a lead in to what you have to do next. Okay, in this example, not very much additional help given to how you have to do it. They then give you some information including the formula and a displayed formula, which is quite useful because it shows that this chemical has 2 single bonds. It then gives you an instruction: complete the diagram below. Quite often students miss out these sorts of questions because they don't recognise that key word complete as telling them there's a question there. They then say use dots and crosses, so we have to make sure that we are doing what the question tells us. It also says you need only show the outer shell electrons. So, how do we work out the outer shell electrons? There are two ways of doing this. The first way of doing it is to look at the information they've given you, the atomic numbers, and that tells you the number of electrons, and to work it out from first principles. Or you can use the periodic table that they will give you to look up the two elements that you need. Hydrogen only has one electron, so it only has one outer electron, because its one electron is also its outer electron. But when we look at sulfur, we see that sulfur is here, 16 number of electrons, but the shortcut is at the top here. The group number tells us the number of outside electrons, so that tells us that sulfur has 6 in its outer electron shell energy level. So now we know this, we have to start drawing. We need to decide which is going to have dots, which is going to have crosses. Just because I've decided to do it that way, I'm going to do a dot for each hydrogen and crosses for the sulfur. So, a covalent bond has to be a pair of shared electrons. So we're going to do a dot for the hydrogen, and then in the overlap with that dot, we're going to put a cross, and that is the pair of shared electrons here and the pair of shared electrons there. So remember I said that the dots were hydrogen, so we've used up 2 of our 6 electrons from sulfur. That means we've got 4 electrons left, and they are going to go in 2 pairs around the outside energy level of sulfur. And that is how we do the applying to a new situation. So now here's another example. This is iodine. Now, iodine is not in the top part of the periodic table, but there is no need to stress or fret, because we still need to just use the outer electrons. Okay, so we look at our periodic table and we find iodine. Iodine is on the right, it's a non-metal, it's down here. Now, if you forgot the shortcut, you'd look at 53 and you'd start to panic. But we've got to remember that all elements in group 7 have the same number of electrons. So iodine, because it is in group 7, has 7 outer electrons. That means we need 2 electrons in the overlap, because that's going to give us our shared pair of electrons. And then we've got 6 more for each iodine. So 1, 2, 3, 4, 5, 6. Same again on the other iodine. And if we count up, we should have 2 times 7, should have 14 electrons in total. And there we go, 14 electrons in total. And any other element in the non-metals will involve covalent bonding, because 2 non-metals are what you need for covalent, and they always have a shared pair of electrons in the overlap. They have overlapping on the circles. And they're always non-metals.